Welcome back to Electron Stance. A couple of years ago, I was planning to make a series of videos on electric motors, but I never found the time to do that. I did record a teardown video of a toy car electric motor, so let me just share that with you now. Man, we had great toys when I was a kid. This is a Hot Wheels Sizzler. It's a little battery-powered electric car. Charging port here on the side. It's been many years since I've taken one of these apart. I don't want to tear up the body of this cute little car, but really I'm getting at the motor inside. That's what we really want to look at right now. I'll bet that is melted to hold the body on. Of course, when I was a kid and we were taking things like this apart, we probably were not what you would call gentle. There we go. That's all there is to it. Here's the beauty part. It's this motor that I wanted to see. Cute little motor with the shafts extended out the side, wheels attached directly one-to-one, and this is actually a little rechargeable battery and a switch. That is all. Look at the motor itself. There are two permanent magnets providing the magnetic field through the armature. This little steel cage probably helps complete the magnetic circuit to strengthen the field going through the armature. By armature, I mean this spinning part. How many poles is that? Let's see. Let's make a mark on one of the wheels so that we can tell when we've made a complete revolution. One, two, three poles, and we're back where we started. So that's really a nice little arrangement. You've always got one of the three poles lined up pretty much with the magnetic field. The connections are made through this commutator ring. Okay, let's see if you can see what I'm talking about. There's a commutator ring right there with brushes sliding against it. That completes the circuit. The segments on the commutator ring determine how the electric current flows through the coils in the armature, which pole or poles are magnetized in which direction. So basically, at any given time, you've got the circuit completed through at least one pole that is trying to line itself up with the permanent magnetic field and making the motor spin. As it rotates, a different commutator segment or segments come into play, changing the circuit to bring to magnetize the next pole and keep it spinning. Looks like one of the brush springs and terminals is really badly corroded here. We're going to make that motor spin. Oh yes. Oh, look at that. I forgot about that. These batteries just push down in here. Spring-loaded battery contacts complete the circuit. You could just easily pop a new battery in. Of course, everything's all corroded here, so that's not going to work. Let's look at how the switch works. Just a plastic lever on the bottom. You push it to the off position and this contact is just pushed up away from the motor. You put it in the on position, and the spring contact pulls itself down against the motor. Here's the circuit. One side of the battery goes here. That spring contacts this terminal right here. The other side of the battery goes through here, and that spring contact completes the circuit to the case. You can see that terminal is connected to the case of the motor through this soldered wire. I don't think you can get the motor out without removing these spring terminals, so we'll probably have to bend them up out of the way and then bend them back down if you actually wanted to repair this car. The motor just pops out though if you bend this contact out of the way. There we go. Here's the motor from the bottom side. Better view of the commutator. You know, I may look at that under the microscope with the camera to get a better view of the commutator rings. But in this motor, the brushes are actually just a wire made of some probably bronze alloy. That's a springy material. And the springiness presses one end of that wire against the commutator segments. Okay, let's see if I can get a good close-up here of the commutators and brushes on this little motor. So there's the commutator turning. You can see that each one of the 3 coils on the armature poles is connected to a couple of different segments on the commutator. As I turn the wheel and spin the motor, spin the armature, you can see the commutator turning, and you can see the segments of the commutator coming past. There's a brush on each side of the commutator. In this motor, each brush is really just a wire, a whisker of a wire made of some springy bronze alloy or something like that, some copper alloy. And as the commutator turns, it makes and breaks circuits through the different coils in the motor. You can see one of those brushes is really corroded badly. I'm going to clean it up a little bit, and then I'm going to apply a few volts and see if I can get this motor to spin on its own. So we're looking at the terminal and brush on one side of the commutator, the side that's corroded really badly, and I'm gonna try to clean some of this off. I assume there's still a good connection between the wire making up the brush and this little tab on top, which is where the leaf spring contact was hitting it coming from the battery. So I'm gonna apply some voltage there and to the body, to the contact points that were used in the car after I get it cleaned up a little bit. We've got to make sure that the wire at the commutator end is clean enough and the commutator segments are clean enough to make a good electrical contact, and that we can make a good enough electrical contact to this tab here. And that's really all we need to do. It doesn't have to be pretty. Okay, so I'm just cleaning up the motor. Looking at it from the bottom side gives me a better look at the commutator segments where the action is, where the wires hit it. Looks like it's gonna take some scraping to get some of that corrosion cleaned off. It's one of the brush wires that's gonna need a lot of cleaning. I'm gonna have to clean this up better later. Gotta go run some errands. So let me just let it soak a little bit. Maybe I should put it in a little cup and soak it. Soak the whole frickin' motor in some isopropyl alcohol for a little while. So when I come back, it'll be easier to deal with. Okay, so I have cleaned up the commutator and brushes somewhat. Unfortunately, that's mostly by scraping away the salts and oxides with the tip of an X-Acto knife or a small flat-bladed screwdriver. I use both on this. This is the brush on the nasty side. Basically, this is the end of a coil of spring wire. You can see it. I can push it out, but it springs back against the commutator segment next to it. On the other side of that coil, that wire is soldered to this metal contact here. So on the other side, everything is much cleaner. You can see the same spring wire pushed away and springs back against the commutator segment. And on the other side of the coil is down here, and it's a coil wrapped around a steel peg or metal peg of some kind. One side's free to push against the commutator. The other side is soldered to an electrical contact, and that also fixes one end of the spring coil and helps provide this spring action here. Alright, this motor should run if I apply power to it now. Okay, so I've got this 4.5 volt battery pack, and I'm going to make a temporary connection to the motor. Okay, so the motor is spinning, and if you look really closely, you can see the arcing at the point where one of the brushes contacts the commutator segments as the motor spins. That brush is still in need of a good cleaning, so probably if I were going to put this car back together and run it on a track, I would take the motor apart, take that wire spring out and clean it up good and put it all back together, and that would be a lot of work. So there's a Hot Wheels Sizzlers motor running. The arcing that you saw on that brush would be generating a small amount of ozone. If you had the same thing going on in a larger motor, you would smell it before long. I believe I said I was going to take this motor apart, so let's do that now. Focus! That's what they used to yell in the movie theaters when I was young. There's the motor. I pulled the wheels off. The motor has a metal housing, probably steel with some kind of tin plating or something like that that's been flaking off on this old motor. On three sides there's the steel cage, and then on the end there's a plastic part to mount the brushes to. There are these little tabs on the enclosure that are bent over to hold the plastic end panel in position. Let me see if I can bend them up without stabbing myself with this little screwdriver. It's only a finger. That's what they told me in the emergency room. That's another story. Now that plastic end panel should slide off. Now that those tabs are out of the way. There we go. And the armature is coming with it, but there's some terminal or something that's trying to hold it back, so I better look around and see what that is. Ah, yes, of course. This wire looks like it's tack welded to the housing based on the heat discoloration there. It's probably soldered at this end because that's like a brass or bronze terminal that solders well. You know what? Let's just cut it. I can always solder it back together if I decide to put the motor back together. Clip. And there's the armature free. Still attached to the plastic end panel. Here's the metal housing. Steel housing, no doubt. With the magnets, these permanent magnets, pressed into it. They may be glued as well. You can see there's a little bearing or bushing in the end there. No need to take the magnets out. Let's remove the armature from the plastic end panel. The brushes are still touching the commutator segments. Let's see if I can see that. Yeah, but they should just slide out of the way. There we go. There's the armature. I can clean that up a little better now that the motor's apart. Here are the brushes. You can see one of those is really nasty. Okay, so there you can see the brush on one side is in pretty good shape. The metal where it contacts the commutator looks pretty clean. The spring is in good shape. The round peg here is just to hold the spring in position. The other end of the spring wire is soldered to this terminal here. The spring on the other side is nasty. It's covered with corrosion. I will have to at least clean up the contact area. And I have bent the spring out. It wasn't making very good contact mechanically with the commutator, so I bent it out to give it a little more spring force against the commutator. So if I clean that up, I can put the motor back together and it'll probably run reliably. I'm not sure I'm going to do that, but anyway, here's a good look at the innards of this cute little toy motor. That's it for now. See you next time.